The dashboard of this AI-powered Railway CTC. Uh, in this, we can see the current system time, and this has different key performance metrics: punctuality, average delay, throughput, track utilization, energy efficiency. So we can start the simulation, and over here we can see the CTC panel and basically everything that is happening. So if we pause the simulation and currently click on one train, we can see the details of that train: current speed, delay status, position, and the next station, and the signal aspect of it. So it can be done for different trains. Over here we can see the delay that is there on that train, and over here in the control panel we can see we can set different sort of weather conditions based on the current weather conditions. We have overriding capabilities for the controller, emergency stop or signal overriding. And then over here we can see the system status. AI models are active, conflict detection is currently running, and recent ML machine learning actions have been, these are the actions that have been performed. So if we go to the different tab, over here we can see the different trains that are currently active in this live track status. So there are currently 6 trains active, and we can see all of their routes, position, speed, next station passengers. The color also are assigned differently to different kinds of trains. Blue represents the express trains, green represents the local trains, orange represents the freight trains, and the purple represents superfast trains. And naturally they have been assigned a certain amount of priority. So over here we can see all the active conflicts that are there, and the priority of those conflicts. So all of these are medium priority conflicts that are running. So if we run the simulation once again, so this will get updated in real time, and all of these things will get resolved. And then we have a anomaly detection area as well, in which different anomalies would pop up if there are any currently. If we move on to the next tab, the analysis. So this tab has the what if scenario analysis that basically tells us what would happen if all of these things were to happen. So if we select, for example, train breakdown and run the AI analysis, so it will give us a detailed breakdown of what would happen next in the CTC panel, and it gives us the confidence that with which the model has actually given this prediction. So right now for this, it has a pretty high confidence that this would happen if the train breakdown of this particular train were to happen. In the alerts tab, we can currently see the system alerts that the model has predicted. So things like train, this is severely delayed and how much it is behind the schedule, or speed advisory alerts. And if we start the simulation, so it will get updated in real time, and the model will solve this, or the humans in the loop will solve this, and it will get rectified. Here there is an audit trail which basically keeps a tab of everything that is happening, be it by the AI system or the controller. So it keeps a tab of everything that happened in this dashboard and in the backend by the AI. So here we have explored how AI transforms railway operations. This dashboard delivers real-time tracking, predictive conflict detection, machine learning powered anomaly alerts, 5 key performance indicators, 10 stations, 6 active trains, all managed intelligently by artificial intelligence, human operators for safer, more efficient rail transfer. It also tells us the weather impact simulations and strategic what if scenario planning. We can expand this architecture from divisions to zone to nationwide. So, right here we can see this is a simulation of a very basic feature of our AI model. So, if I start this simulation right here, we can see that all of these trains, basically the blue, yellow, red and green, they all have to use this main track in the middle, which is A. But since these two have a higher priority than the blue and the green, the system lets these two trains first cross this entire block. So if I run it again, it first allows these two trains to cross this entire block, and at the same time the speeds of these two trains are slowed down, and once these two trains leave or exit this block, then they are directed towards this main track again, and they follow their rules as directed. So over here in this setup we have multiple tracks with different trains of different colors representing different services. Each train moves along its designated track, and the speed of each train is intentionally reduced so that we can observe the simulation clearly. So right here, this is the main track, and these three are the branch tracks. And below over here we can see the dispatcher dashboard. So this dashboard has the details of the trains that are currently active. So we can see there are 2 express trains, 1 mail train, 2 local trains, 1 freight train, and the track that it is on currently. This shows the block that it is occupying. Basically, Kalyan to Shahad is considered as one block. Shahad to Ambivli is considered as another block. So it tells us the block that it is occupying. This tells us the priority of the train, and it is indicated by the number. So higher the number, higher is the priority of the train. This tells us the status of the train at this current point in time, and this tells us the weight. So if we run this simulation, and basically this table gives us live info. So this actually changes dynamically once we run the simulation, and it tells the position of each train and the state, giving the controller a clear overview of track usage. So if I run this simulation right here, we can see that all of these changes are dynamically being overwritten in the dispatcher dashboard. Also, we can see that the signals, these green blocks and red blocks, are the signals of individual blocks. So right now at this point in time, when I've paused the simulation, this has been turned into red. So this basically means that the current block is occupied by this train, so the previous train cannot enter this block. And so this was about the signals. There is also this overtaking scenario. So over here we can see there is a freight train and this is a mail train. So if I run the simulation, so the mail train is allowed to pass the freight train at first, and while it's passing, the freight train actually remains stationary, and first it allows the train to pass, and then the freight train slowly starts to move. So this is done on the basis of priority. Basically, the mail train has a higher priority than the freight train. So these two simulations that we have just shown basically gives us an overview of how the ML model would predict and give outputs in these type of scenarios. This model can be extended further to integrate real-time data and AI-based decision making, and it is a strong foundation for smart railway management systems.